This section is about the techniques of integration. I chose this problem because when you look at the problems, a lot of people got confused, probably because of the square root of 2 in the exponents right here. But hopefully you can see it's just a number. And for this problem, you just have to use u substitution. So if I let u to be 3x plus 1, du turn into 3 dx. So as you can see, we just divide by 3 here. And then we can just go ahead and use the u substitution. Before I use the u substitution, I probably need to change the limit. So when x equal to 0, u is going to be 1. When x equals to 1, u is 4. So now I can just write 1 and 4. And I have u to the square root of 2, 1/3 du. So I can take the 1/3 out. And for the integration, I'm just going to leave plus 1 like that. We don't have to use a calculator. We can just write down the number. And then I want to evaluate from 1 to 4. So it's going to be 1/3 square root of 2 plus 1. And then we have 4 square root of 2 plus 1 minus 1. And that's my final answer. For this problem, I would start with u substitution. So if I let u be 1 plus e to the x power, du would be e to the x dx. So you can see right here, we should rewrite. E to the x should be u minus 1 dx. So if I go back and rewrite, I would get 1 over u times du over u minus 1. So you can see that we have the fraction like this, 1 over u times u minus 1 du. So for this part, we're going to have to go back and do partial fraction. So 1 over u minus 1 turn into an a over u plus b over u minus 1. Now I'm going to multiply both sides by the LCD, which is u times u minus 1. So I'm going to get 1 for A. I ended up with u minus 1. For B, I ended up with u. Okay? So if I let u to be 1, I get to cancel out this one right here. So I'm going to get 1 equals to b times 1. So you can see that b is 1. Now, I'm going to go back and let u to be 0. So I can cancel this one right here. So I get 1 equals to a times 0 minus 1 is negative 1. Therefore, a is negative 1. So we're going to go back and rewrite the integration. So the integration turned into a negative 1 over u plus 1 over u minus 1 du. And when we integrate, we get negative ln u. The absolute values plus ln the absolute values of u minus 1 plus c. And then I could just go back and put the 1 plus e to the x in. So I get negative ln 1 plus e to the x power plus ln e to the x power plus c. We can definitely simplify this part right here. So I should get x minus ln 1 plus e to the x plus c. And that's my final answer. Every time you have the trig functions, the first thing you should do is you should try to simplify it using all the trig identities that you know. So for these fractions, I would first try to simplify it. Cotangent is turned into a cosine theta over sine theta. Secant is going to be 1 over cosine theta. So you can see that we cancel out, and then we have cosine over 1 over cosine. So this one turned into a cosine square theta. If I go back and rewrite, so we want to integrate cosine square theta. So you can see that we don't have the antiderivative for that one. So we should use another identity, and that's the double angle. So this one should turn into a 1/2, 1 plus cosine 2 theta d theta. And now we can integrate. So I got 1/2 theta plus 1/2 sine 2 theta. Evaluate from pi over 6 to pi over 3. So I still have that 1/2 pi over 3 plus square root of 3 over 4 minus pi over 6 plus square root of 3 over 4. So we simplify it. We get 1/2 pi over 6, which is pi over 12. For this problem, when you see the square root of 4x squared plus 1 like this, you should think of the trig substitution. So you can see right here is 2x squared plus 1 squared. So I'm going to let 2x to be tangent theta. So x is going to be 1/2 tangent theta. So we take the derivative, dx turn into 1/2 secant square theta d theta. So you can see that square root of 4x squared plus 1 should be secant theta. Now, we're going to go ahead and rewrite. This is the original problem. Dx over x square root of 4x squared plus 1 turn into dx, that's 1/2 secant square theta d theta over 1/2 tangent theta secant theta. So we're gonna do some simplification so I can cancel 1 secant, cancel 1/2. I ended up with secant theta over tangent theta. Now let's rewrite that. Secant theta is 1 over cosine theta. Tangent is sine over cosine, so I'm going to multiply cosine theta over sine theta because we multiply by the reciprocal, d theta. So that's turned into a 1 over sine, which is cosecant theta, d theta. And that's going to be negative ln absolute values of cosecant theta plus cotangent theta plus c. So now I'm going to go back and use x. So before we do that, we need the triangle. So that's my theta right here. So originally we have x equals to 1/2 tangent theta. So tangent theta is 2x over 1. 2x over 1. Tangent is opposite over adjacent. So this one right here is going to be 4x squared plus 1, the hypotenuse. So what I have is negative ln cosecant is going to be the hypotenuse over opposite. Cotangent is adjacent over opposite plus c.